Here we go. Again, most of what we're talking about today is going to be linear equations. Let me show you how to recognize linear before you even start. Anytime you have an equation with two variables, x is to the first power, y is to the first power, and it's not in denominators. Anytime you have that type of equation, y equals 4x plus 5. 6x equals 2 minus 5y. All these equations are linear. Okay? We call them linear because when you graph them, you get a line. The first way we're going to talk about graphing these is graphing using intercepts. There's actually two different ways. We'll do this. We'll do the slope-intercept method. You've seen this, hopefully, once or twice. One other thing I do want to point out, and know this, start somewhere in your notes, know it for the rest of this class and calculus as well if you take it. In order to find an x-intercept, y equals 0. In order to find a y-intercept, x equals 0. So an x-intercept looks like some number, comma, 0. A y-intercept will always look like 0, comma, some number. So if from here on out I ask you, okay, how are we going to find the x-intercept? Plug in 0 for y. How am I going to find the y-intercept? Plug in 0 for x. That's all you have to do. A reminder, if you don't remember, an x-intercept is simply where a graph, I'm not going to say your line because later on we'll talk about x-intercepts and parabolas, cubic, quartic equations, and all this. An x-intercept is simply where your graph crosses the x-axis. If your graph looks something like this, it might have several x-intercepts. A y-intercept is simply where your line crosses the y-axis. If it is a function, it'll cross it once and only once. If you remember functions, point above points, that's not a function, so that's the reason it can only graph it once, or cross it once. Graph each equation, be sure to find and show the intercepts. When a line is in what's called standard form, where you have x stuff and y stuff equals number stuff. If it's in standard form, by far, hands down, the easiest way to graph this thing most of the time is going to be find x and y intercepts. Again, Caleb Haynes, remind me, how do I find an x-intercept? Y is good. So watch how I do this, guys. There we go. Y is 0 is gone. You're left with 2x equals 9. Everybody solve that pretty easy? What's x? Good. 4.5. Divide by 2, right? 2x equals 9. Divide by 2, you get 9 divided by 2, 4.5. Everybody good there? So your x-intercept of this equation, 4.5, just put it there. Here's your x-axis. Put a point at 4.5. Your y-intercept now. Student, remind me, how do you find a y-intercept? Make x 0. Now that's gone. Negative 3y equals 9. Divide by negative 3, guys. What do you get? So my y-intercept is negative 3. From geometry, can you tell me how many points to find a line? How many points do you need to define a unique line? If I give you 1 point, there's infinite lines you can draw through it. But if I give you 2 points and I say draw a line through it, can you? There's only one line possible, right? Done. So the graph of 2x minus 3y equals 9, get you 2 points, connect the dots, you're finished. Okay? That's pretty easy. One more of those. I don't like this problem. Look at my scale. 40 minus x. X-intercept, y-intercept. Skyla, find my x-intercept by plugging in 0 for y. So we get 0 equals 40 minus x. What is x? 40 minus what? And I know what you're doing. Guys, look at this. Sometimes we've solved equations for so long, sometimes we overthink them. 0 equals 40 minus something. What's that something? 40 minus 40, right, is 0. So if y is 0, my x has to be 40. What about my y? In order to find my y-intercept, we're going to plug in 0 for x. Brianna, do that for me. Plug in 0 for x, you get y equals 40. Thank you. So I have an x-intercept and a y-intercept of 40. Unfortunately, I only have like 8 boxes there. I don't have 40. Okay, so we're going to have to change our scale to get this even fit. If we let each box count 5, 10, 15, 20, 25, 30, 35, it would nearly fit. So let's let each box count 10, 10, 20, 30, 40. And you can put some numbers on here just to show me 10, 20, 30, 40, 50 if you want to, just so I'll know that you changed your scale. 10, 20, 30, 40, 50, and you could put one over here too. But my x-intercept is 40. My y-intercept is 40. Connect the dots. You're finished. Any questions? To graph with the intercept, simply find your x-intercept, y-intercept, connect the dots. Graphs of horizontal and vertical lines. These are fast, easy. When we start talking about asymptote lines, we'll do a lot of vertical line graphs, so please remember these. X equals 4. This is my x-axis. This is the mistake most people make. There you go. There's the graph of x equals 4. No, it's not. Okay, that is a dot. That is a point. That is not a graph. If I asked you to plot the point 4, 0, okay, we're good there. Truth, x does equal 4 here, but I believe this is the point 4, 1. This is the point 4, 2, 4, 3, 4, 4. X is also equal to 4, all of these places. So the graph of x equals 4, or x equals any number, is a vertical line. Here in a second we're going to talk about slope, and I'll go ahead and hit on it here. Anytime you have a vertical line, reminder that the slope would be undefined. Go ahead and talk about it now. Slope is undefined. So anytime you graph x equals a number, there's no y here. X equals a number, vertical line. Y equals a number. Well, here's y equals 3. But that's not the only place y is equal to 3. Y equals a number will be a horizontal line. Notice there's no x. This is not y equals 3x. This is y equals 3. So how would I plug x values in for this? If x is 1, y is 3. If x is 2, y is 3. That's what it says, y is 3. If x is 3, y is 3. If x is 1 million, which is way over here, y is 3. That is a horizontal line. And that would be a 0 slope. Slope equals 0. We've solved equations already with the graphing calculator. I will remind you how to do that if I can get mine to pull up here. If I can find it. Okay, here we go. Every equation that we've solved up to this point had stuff on the left side, stuff on the right side. Well, you do have stuff on the right side. But listen close to this. You're going to graph this left side. It will be a line. How do I know it's a line? If you distribute this, x is to the first power. If you add this to x is still to the first power. So if you graph this on your graph calculator, y equals this, you've got a line. If you graph y equals 0 on your graphing calculator, that is a line. Which line is it? Think about where y equals 0 is located. What is y equals 0? Thank you. That is the x-axis. The line y equals 0 represents your x-axis. So what am I looking for here? I'm looking for pretty much where this crosses this or where this crosses the x-axis. So this is actually an easier way to solve these. Let me go ahead and type that in. Have y equals. Just type it in as is, x minus 3.45 plus 13.98. And you don't have to graph y equals 0. So if you work it this way to where you have everything on one side and y equals 0 on the other side, you just have to graph the one side. Okay, we're nowhere near where it crosses. Okay, we're going to cross somewhere way over here, so let's change my window. Let's run from negative 20 up to 0 on my x-axis and just see if that, well, we're close. Let's see that. Here's my line. Let's go to negative 25 on my x-axis. There we go. So we're crossing somewhere right here. because again, we're looking for where does it cross the x-axis. Instead of using your normal intersect tool, if you're only going to use one line, look at here, 0. We're looking for this line's 0 is what it's called. It's x-intercept. A 0 and an x-intercept is the exact same thing. So you go to 0. Now this is a little bit different. It asks you for a left bound. Let me explain what you're doing here. You're looking for, or you have to tell your calculator, okay, give me a value that's on the left side of where it crosses. Because what if it crosses a bunch? You've got to tell your calculator which one you're looking for. I'm looking for this one. And I know, since my window runs from -25 to 0, I know -25 is on the left side, so let's do it. So my answer is between -25 and, let's say, -15. You just have to tell it about where it's at. So between, and you see it puts the arrows up here. There's an arrow, there's an arrow. Guess, you don't have to. -21.96818. That's your answer. Ugly decimal. So again, anytime you have 0 on the right side, instead of using the intersect function, you can use the 0 function of your calculator. Okay, shortcuts. Slopes and intercepts. Any equation of the form y equals mx plus b is in what's called slope-intercept form. The reason we call it slope-intercept form is because the n stands for your slope. And if you don't remember, slope is how slanted a line is. We'll go over the formula in just a second. B is what's called your y-intercept. That's where we've already discussed intercepts. Your y-intercept is where the line crosses the y-axis. Here's your definition of slope. Slope is the change in the y-coordinates over the change in the x-coordinates. Most of the time we write that as y2 minus y1. You can put these on your formula sheet if you'd like. Over x2 minus x1, if you don't know them already. If you want to go college on me here, there's how we write it in college, delta y over delta x. Delta it is a triangle, but it's not a triangle. Delta is a Greek letter. Alpha, beta, gamma, delta, right? It's your fourth letter of the Greek alphabet. It's your D. Okay. Anytime you see that triangle, and we do use it a lot in calculus, that triangle means change. Okay, so delta y over delta x means the change in y over the change in x. That is simply all that means. You don't have to put it if you don't want to. And we also know that slope is equal to rise over run. First problem, in each case, find the slope of the line. y2 minus y1 over x2 minus x1. The second y minus the first y. Colby, what is y2 minus y1? Just do the top. Second y minus first y gives you, perfect. Over, go ahead, Kobe, and do the bottom two. -1 minus -3 gives you +2. Perfect. Make sure when you're subtracting, -1 minus, this minus is built into the actual formula. It's x2 minus x1. This minus is tacked onto the 3. You have to put both of those minuses, and like he said, you got a plus there. -1 plus 3, which is 2. Anytime you're dealing with a fraction, divide it, reduce it, leave it. Divide it if it'll divide, reduce it if it won't divide, and leave it if it won't do either. This will divide. -6 divided by 2 is -3. A slope of -3 is a downward slope. That you get that from the negative. If it were a positive slope, it'd be uphill. 3 tells you how steep it is. 3 is a fairly steep slope. I'd hate to roof that house. y2 minus y1 over x2 minus x1. Brett, what's y2 minus y1? Try it one more time. y2 minus y1 is... I saw it. You did the net -3 there. And then x2 minus x1 honestly doesn't even matter. It's some number. It's a, but it doesn't matter. 0 divided by a number. Just a reminder. 0 divided by a number is 0. That is legal. But a number divided by 0, you cannot do. Here's how I describe that. If you have 0 candy and lots of friends, you remember that? If you have 0 candy and lots of friends and you want to divide your candy amongst all your friends, you can. They will all get 0 candy. But if you have lots of candy and no friends and you want to divide it amongst your friends, you can't do that. Okay? Sad story. y2 minus y1 is 3. x2 minus x1 here is 0. That is an undefined slope. That is a vertical line. Vertical lines all have undefined slopes. A number divided by 0. Cannot do. And you can look at that. -3, 5 and -3, 8 would look something like that. That is a vertical line. There is a slope-intercept form that I described a while ago. Anytime an equation is in this form, you have y on one side, you have equals, you have x stuff, and you have a number. That number could be 0. Anytime it's in this form, it's in slope-intercept form, and it can be graphed extremely easy. Identify the slope and the y-intercept of this line. This is not in that form. Usually within 2 steps you can get an equation from standard form into a slope-intercept form. Let me show you how to do it. Step number 1, to get this in slope-intercept form, any non-y term, move it to the right side. We now have -3y equals. There's 3 terms here. To move a term from one side to the other side, simply change its sign. 2x will turn into -2x. Notice I wrote my x term first. Why? Because slope-intercept does y equals the x term plus the number term. Last step, divide by -3. Mark it out. Make sure you divide it all by -3. Divide it, reduce it, leave it. 2 and 3 will not divide without giving you a decimal. But negative divided by negative, we can reduce that. Negative divided by negative is a positive. 2/3 will not reduce. Divide it, reduce it, leave it. 6 divided by -3 is a -2. So now it says identify the slope, identify the y-intercept. I now have it in slope-intercept form. My slope of this line is 2/3. My y-intercept is a -2. Any questions? How do we graph once it's in this form? If it's in this form, again, we have a slope here. I'm going to put this 3/1. We have a y-intercept here. Really the only mistake, because you've seen this so much, really the only mistake I want to caution you of is make sure you put the y-intercept on there first. And it's a y-intercept instead of an x-intercept. -1 is where your graph crosses the y-axis. So put a dot there. Slope is equal to rise over run. So this line will rise 3 and run 1. If it's not slanted uphill, it's wrong. Okay, that's a positive number. So from that dot, make sure you rise 1, 2, 3, and you run 1, and you continue doing so over and over and over. 3/1 is the same thing as -3 over -1, because a negative divided by negative is also a positive. So instead of going up 3 and right 1, you could also go down 3 and left 1, and it's going to follow on that same line. Connect your dots. Put arrows on each end, because it goes forever. You're done. That's graphing using slope-intercept form. Y equals -2/3 x plus 4. Noah, where am I going to put my first point? Up, down, left, right. 1, 2, 3, 4, right there. From that dot, Henshaw, where am I going to go? And make sure it's negative slope, so we need it to slant downhill. Down to left 3 be uphill, down to 1, 2, 3 to the right. Down to 1, 2, 3 to the right. Just make sure when you go down to left 3, make sure you don't put this negative on both of them. If it's one negative, you can put it on top, you can put it on bottom, you can put it in either place. If you put it on bottom, that would also be up to, and 1, 2, 3 to the left would also work. Same line. Connect the dots, draw arrows on each end, finish. Okay. If you're actually looking for an equation, we're going to work it backwards now. If you're looking for an equation, I'm going to show you 2 methods of doing this. You pick the way you like best. I'm going to teach what's called point-slope formula. If you want to write that down, go ahead. Y minus y1 equals m times x minus x1. To where x1, y1 is some point on the line, and m is the line slope. So if you're given a point and a slope, and you're looking for the equation, plug in the point here and here, plug in the slope here, leave the x and y, because your formula needs to have x's and y's in it, and you're done. Just clean it up and you're finished. The other way, I'm going to show you how to work the exact same problems using slope-intercept form. You pick the way that you like best, you work it, you get them all right. I don't care. Just get them right. As long as as you work it. Methods. If you want to use point slope, and again, the reason we call this point slope is because you plug in a point and you plug in the slope. We're trying to be creative with that name. Trevor, help me. We're looking for the line that passes through this point. Excuse me. There we go. I went 12-year-old there for a second. Here, we're looking for the equation line. Here's your point. Here's your slope. So what are we going to plug in for y1, Trevor? Point slope. 3, good. What's my slope? Good. And x minus -2. Perfect. Any questions? Minus minus, make it a plus. Cleanup is all we have left. I mean, that's the equation. You're done. Okay? That's an answer. But that answer is in point slope form, so let's get it in slope intercept form. I like leaving all answers in slope intercept. Distributive property, 1/2 times x. 1/2 times 2 is the same thing as 1/2 of 2. -3 turns into +3 when you move it across the other side. You have y equals 1/2 x plus 4. That's the equation line that passes through the point -2, 3. And you can prove it. Plug in -2, you should get 3. That means that point is on that line. It should have a slope of 1/2. It does right there, 1/2. If I ask you to graph that within 10 seconds, +4, rise 1, run 2, connect your dots. Okay, graphing is that quick now. Let's look at the other method of solving this. You pick the method you like best. I like this one. I start out with y equals mx plus b. That's what I'm looking for, is my slope-intercept formula. I already have slope. That's half my answer. I've just got to figure out the other half of my answer. Plug in this x and plug in this y, and that will tell you what your b value is. So I now have, when I plug those in, y is 3. When you multiply 1/2 times x is -2, 1/2 of -2 is -1, and you're looking for what b value is there. Solve that one step. Turn -1 into +1 as you move it over, and you get +4. Same answer. My b value is 4, so go back and put 4 where your b is at. Y equals 1/2 x plus 4, same answer either way. Same thing, but what if you're given 2 points? We're looking for the equation line that passes through the point -1, 4, and 2, 3. You can, again, work it either way you want to. I'll work it y minus y1 equals m times x minus x1. We're plugging in a point, x1, y1, and we're plugging in a slope. I don't have a slope, so find a slope. To find a slope, come over here to the side. Slope is equal to y2 minus y1 over x2 minus x1. Lydia, help me with that. What's y2 minus y1? Perfect. What's x2 minus x1? Go ahead and do that too, Lydia. So -1/3 is my slope. So plug that in for my slope. Now, which point do I plug in? It does not matter. I'm going to plug this one in just to show you that I'm not afraid of negatives. So we have y minus y1. If you plug in either point, you should get the exact same answer. That's a good way to check it. Y minus y1 equals m times x minus x1. Y minus 4 equals, that's minus minus is a plus, -1/3 times x, -1/3 times 1. We're going to move -4 over here by doing +4. Let's go ahead and do common denominator as we're moving it. Anna Marie, I need a common denominator of 3 on the bottom. So multiply top and bottom by 3, and 4 turns into -12 over 3, which is going to be +12 over 3 when I move it across. Good. Everybody good with that common denominator? Multiply top and bottom by 3. So you now have y equals -1/3 x Negative 1 plus 12 would be plus 11 over 3. Pretty ugly. Okay, here we go. 2, 5 and negative 6, 5. Which ones? Yes, I sure will. Actually, let's go back and work that last one that way because this next one's going to be a little bit shorter. Here's, she wanted another one the other method. Y equals mx plus b. Now this one might be a little bit tougher. I don't know. We'll see. I know half of my answer. I know my slope is negative 1/3. And you still, if you're given 2 points, your first step, you still have to find the slope first. So I now have y equals negative 1/3 x blank. I don't know my plus b. Okay, I don't know the rest. I don't know my 11/3 yet. You don't see any 11/3 anywhere up here. Here's how you find the other part. Actually, you know what? I'll use the other point this time, just to show you that either point will work. I'm going to plug in my x. I'm going to plug in my y. That will tell me what my b is. Here we go. My y value is 3. My x value is 2, or 2 over 1. Multiply tops, multiply bottoms gives you negative 2/3. And I'm looking for what that plus b is. Get a common denominator. I believe it's going to be a 3. Multiply top and bottom by 3. What does this turn into? Anybody? Thank you. So now I have 9 over 3. I've got to move my minus 2 over 3 over here. 9 over 3 plus 2 over 3 is 11 over 3. So my b value is plus 11/3. So if you want to use shortcut, find your slope, plug in an x and y, and that'll tell you what your b is. So now you have a slope, you have a b, plug them both in, final answer. Okay. On this one, picture these points. Go over 2, go up 5. Go left 6, go up 5. What kind of line is that? Go right 2, go up 5. Go left 6, go up 5. That is a horizontal line. How do I know it's a horizontal line? Look at your y values. You go up the same amount each time. What do horizontal lines look like, equation-wise? Y equals a number, right? Don't spend too much time on these on your homework. Y'all know what that number is on this one? What's y equal? 5. Done. Right. If you need to see another one work, 1, 3, 4, 3. What is y equal? 3. Done. Okay. If you have a repeat y or repeat x, you're either going to have a horizontal or a vertical line. Those are really fast problems. If you would like to, I don't know why you would, but if you would like to work it out the long way, you can find slope, y2 minus y1 over x2 minus x1. You'll get slope as 0. You could plug that into y equals mx plus b. This is 0. So that would be y equals 0x plus b, or just y equals b. Plug in either point. What do you plug in? Well, take out the y, put in 5. In either point, you get b as 5. Go back, plug that in, y equals 0x plus 5. Y is 5. Same thing. Okay, look at this one. Kind of the same thing, except for this is a vertical line. 3, negative 1, 3, 9. If you plot those 2 points, you end up with a vertical line. Anybody want to take a stab at the equation? X equals 3. You have repeat x's there. That's a vertical line. Both x's are 3. If you would like more points on that line, 3, 7 is there, and 3, negative 5 would be there. 3, comma, anything is there. X is always 3. And we will stop there for today.